Question 1 from the multiple choice of the 2024 Higher Physics exam from the SQA. A cyclist travelling along a straight track accelerates at 1.2 metres per second every second. The speed of the cyclist increases from 4 metres per second to 7.5 metres per second, and we're asked to find the distance travelled by the cyclist during this acceleration. This is a kinematics one. We put down our favourite characters U, V, A, S and T. U being initial velocity, which we know is going to be 4 metres per second. And we know the final velocity is going to be 7.5 metres per second. And we know that the acceleration is going to be 1.2 metres per second every second. And we're asked to find the displacement or the distance travelled here. So identify what variables we've got. We have got U, V, A and S. And we go to our relationship sheet and find out that the equation we're going to use is going to be v squared equals u squared plus 2 times the acceleration times the displacement. Now all we have to do is to rearrange for the displacement, and it's something we should have practiced. V squared minus u squared is going to give us 2 times acceleration times displacement, and therefore v squared minus u squared, put a bracket around that, divided by twice the acceleration, 2a, is going to give us the value for the displacement. So we'll put in the numbers, and s is going to be equal to the final speed, which is going to be 7.5, and we're going to square that. Take away the initial speed, 4.0, and we're going to square that as well, and divide by 2 times acceleration, which is 2 times 1.2. So we do that in our calculator, we end up with a value of 16.77 in our calculator's metres, and therefore we round that to 2 significant figures, 17 metres in 2 significant figures, and the answer for that is going to be answer B on our sheet. Question 2 from the 2024 Higher Physics examination. A ball is thrown vertically upwards and returns to its original position. Neglecting air resistance, which displacement time graph represents its motion? And you can see we've got a full lot of graphs there. We've got the first one A, B, C, D and E. Now you just have to know this one, and the best way to show it is by a simulation, so as you'll always remember it. Here we have a simulation of a ball being thrown into the air, and you can see the displacement graph on the right hand side. As the ball gets thrown into the air now, you can see that the graph is a very famous graph. It's practically the outline of how the ball travels. So the graph we're looking for is a graph that's going to go up and down in that kind of famous parabolic curve, which is this curve here. So which graph have we got that does that? Well, it certainly looks like it's going to be graph number 1, or graph number A. You can see displacement goes up and goes down in a kind of parabola shape. It's not this one, it's not that one, it's not that one, and of course the final one, E, reminds you of your velocity, so you're guessing at one. It's not that one. So the answer for question 2A, the ball being thrown into the air, the displacement graph is graph A. Question 3 from the 2024 multiple choice Higher Physics. A box is suspended from a ceiling by a rope. A horizontal force F is acting on the box, and the box is held stationary as shown. The weight of the box is 4.9 newtons, and we have to find the tension T in the rope. It's a classic case of understanding all the forces and drawing them all out, and the best way to start this off is to draw a little axis like that, and to represent the box just put a dot in the middle. So that dot in the middle represents the box. Now what you can do is fill in all the forces. Well, we know we've got a force which is the tension on the rope, and that's going to be in that position there like that. We also have got a force pulling the box away from the side, and I'll draw that kind of black force like that there. Now, where's the other forces? Obviously the box has got weight, so there must be a weight force acting straight down like that. Now, because the box is not moving, it's held stationary, there must be an equal and opposite force in the y direction, and that must be exactly equal to the weight. So we have this position up here, and that force must be equal to the weight of the object W. Now the angle is going to be 20 degrees. Now we can check our angles now, because we can draw a little dotted line, and we can draw it down like that, and we know that this angle in here is going to be 20 degrees. So we'll just mark that angle in there, 20 degrees. So if the angle's 20 degrees in there, then it follows from the Z angles that this angle in here is going to be 20 degrees. So there's your triangle you have to find out. You can see that the triangle, if I just put a dotted line across the top of the triangle here like that, you can see we have got a triangle with an angle of 20 degrees. We have got the right angle part there, if I can draw it in. There's the angle part. There's the hypotenuse, which is the tension rope, and there's the angle. So sine of 20 degrees is the opposite divided by the hypotenuse. Now we haven't got the opposite. We could have it because that's the force which has to be balanced in this direction. That's going to be the force in there. But we don't know what the force is. So we have to go to cos 20 degrees. That is the adjacent side divided by the hypotenuse. And that's what we need to find out. So cos of 20 degrees is going to equal to the adjacent side, which is W, divided by the hypotenuse, which is the tension. And therefore we've got an expression for the tension. The tension T is going to equal to W over the value of the cos 20. We know the weight of the object is going to be mg, but we can go straight ahead and say that the weight is 4.9 because that's what we're told, 4.9 newtons. And we've got to divide that by cos of 20 degrees. Now we do that on our calculator, we end up with a value of 5.2 newtons on our calculator. And that seems to be the answer in our sheet, is going to be D in the multiple choice. But you can see how we can do this question. We start off with that dot in the middle to represent the box. We put in the forces shown, the tension force like that, the weight force acting down. If it's stationary, the weight must be balanced by an equal and opposite force up the way, and that's that weight there. And that's going to be the adjacent side of this triangle here. If that's 20 degrees in here, then this is going to be 20 degrees in here. And we've got that triangle to solve. Cos of 20 is going to equal to the adjacent weight divided by the hypotenuse T. Rearrange, put your numbers in, and you have the answer, 5.2 newtons.